in the last lecture we studied the Gauss theorem. Means last lecture means the topic of the 11th standard. The Gauss said that the total electric flux through the body is equals to the 1 upon epsilon naught time the charge enclosed by that body. So now we will see the use of that Gauss theorem. Okay, this topic is actually in the 12th standard of the Maharashtra board. Application of the Gauss theorem. Okay, this Gauss theorem is used to find the electric field intensity of the charged bodies which are uniformly charged, on the surface of which charge is uniformly distributed. For such charged bodies we had to find the value of the electric field intensity. You had the value of intensity for the point charge, that is 1 upon 4 pi epsilon naught k q by r square, that is about point charge. You know the value of electric field intensity. Now that concept we had to extend from point charge to the charged body. So the very first application is to find the electric field intensity E of uniformly charged spherical shell or charged hollow sphere. We want to find the intensity of the charged hollow sphere. So this is the spherical body which is uniformly charged. Charge is present on the surface of the body. Q is the total charge present on the surface of the body. R is the radius of the body. O is the center. Okay, and the surface charge density of this charged body is sigma. Surface charge density is sigma. Surface charge density means charge per unit surface area, that is Q upon 4 pi r square. Okay, now this is the point P which is outside the charged body, where we want to find the value of electric field intensity. यहाँ आपको intensity निकालनी है. So suppose at the point P intensity is E, electric field intensity यह E है, यहाँ मुझे निकालनी है. तो इस तरह इस पॉइंट पे इंटेंसिटी कैसे निकाला जाए? तो इंटेंसिटी निकालने के लिए जनरली इस गॉस थ्योरम का यूज़ करने के लिए यू हैव द 4 स्टेप्स. पहली स्टेप रहती है गॉसियन सरफेस निकालना. सो वी विल ड्रॉ द गॉसियन सरफेस. द गॉसियन सरफेस मस्ट बी should be, not I will say not must, but should, because try to maintain the shape of the Gaussian surface as that of the shape of the body. So this pink color dotted line represent the Gaussian surface. It is a Gaussian sphere which is passing through the point P, where you want to find the value of electric field intensity E. Okay, so the Gaussian surface is here a Gaussian sphere which is passing through the point P. Okay, where you want to find the intensity. Second step is to take the small area element of this Gaussian surface at the point where you want to find the intensity. So this is the ds area element. Okay, the area vector ds makes the angle 0 with the intensity vector. So this is the second step. Take the small surface area element ds. After taking the small surface area element, find the flux for this element. This is the third. And the fourth step is to take the integration for the entire flux and apply the Gauss theorem. So we did it. We taken the small surface area element ds. So electric flux over this small surface area element is, you know the formula, d phi is equal to a ds cos theta, where theta is 0 because the area vector and intensity vector both are parallel. So d phi e ds cos 0, so d phi is equal to e ds. D phi e ds is the flux coming through this much part of the Gaussian sphere. So I want the flux for the entire sphere. So electric flux over the entire Gaussian surface is obtained by integrating the above equation. So flux is equals to integration of d phi. Flux is equal to integration of, instead of d phi, e ds. Okay, now the E is a constant. Why constant? Because every point of this Gaussian sphere is at the same distance from the center of the charged body, that is at the distance small r. So E is a constant taken outside the integration, so phi is equal to E integration of ds. But the integration of ds is 4 pi r square, where small r is the distance from the center of the point P. This is the surface area of the Gaussian sphere or surface. Okay, we will put this value in the equation number 1. So we get phi is equal to E 4 pi r square. Okay, this is equation number 2. इतना flux इस Gaussian sphere से बाहर निकल रहा है. Now what we do, we will apply the Gauss theorem. What the Gauss had said? Gauss said the flux is equals to 1 upon epsilon naught k times the charge enclosed. So phi is equals to 1 upon epsilon naught k q. We will put this value of phi in this equation. So using equation 2 we get, instead of phi, E 4 pi r square is equals to q upon epsilon naught k. So E is equal to q upon 4 pi r square epsilon naught k. Just reshuffle the equation. So E is equals to 1 upon 4 pi epsilon naught k q by r square, where r is the distance of the point from the center of the charged spherical body or spherical shell. So this is the value of, or the formula of, the electric field intensity of this charged sphere, okay, from the center. Now in this equation, instead of a total charge q, you can put the value of surface charge density. You know the surface charge density sigma is total charge upon total area, q upon 4 pi r square. So q is equals to 4 pi r square into sigma. Put this value in equation number 3. So A is equals to 1 upon 4 pi epsilon naught k, instead of q, 4 pi r square sigma upon r square. So 4 pi cancel out. You get E is equals to r square sigma epsilon naught k r square. This is the equation number 4. So the equation number 3 is also of the equation of intensity, and equation number 4 is also of intensity. This is in terms of a total charge. This is in terms of the surface charge density. So this is the first application of the Gauss theorem. Now electric field intensity inside this charged spherical shell is always 0, because charge is present on the surface. Keep in your mind. Inside intensity is 0, electric intensity is present only outside, and it is always away from this charged sphere. Okay.